Hello, ladies and gentlemen, this is Mrs. Gallagher, and today we're going to discuss exponents and multiplication. So let's first discuss the product of powers property. And let's look at example 1. It states, write the product in expanded form. And we have 3 to the third power times 3 to the fourth power. So let's expand that. 3 to the third power means 3 times 3 times 3. And then you're going to times that by 3 to the fourth power, which means 3 times 3 times 3 times 3. So what do we notice here? How many 3's do we have? We have 1, 2, 3, 4, 5, 6, 7. So now we're going to write the product with a single base. Our base here is 3. And our exponent is going to be 7. So your answer is 3 to the 7th power. Let's look at example 2. We want to write the product in expanded form. Negative 4 squared times negative 4 to the fourth power. So let's expand it. We have negative 4 times negative 4. And now we're going to times that by negative 4 to the fourth power. So we have negative 4 times negative 4 times negative 4 times negative 4. So how do we write that product with a single base? Well, how many negative 4's do we have? We have 1, 2, 3, 4, 5, 6. So we write it as negative 4, keep it in parentheses, to the 6th power. So now what did we notice? We noticed that when you have like bases and you are multiplying, you're going to add your exponents. So when we have like bases, we're going to add the exponents when multiplying. So our key concept is to multiply numbers or variables with the same bases, we add the exponents. So our key concept, to multiply numbers or variables with the same bases, we're going to add exponents. So our arithmetic, if we have 3 to the second power times 3 to the 7th power, you're going to add your exponents. So you're going to say 2 plus 7, and that's going to give you 3 to the 9th power. And that's your answer. Now, if algebraically, you're going to say x to the m power times x to the nth power equals x to the m plus nth power. You're just adding your exponents whenever you multiply. So let's do some examples together. So let's look at example 1. It says 6 to the second power times 6 to the third power. They have the same basis. So now you're going to add your exponents so that it equals 6, and you want to add 2 plus 3. And 2 plus 3 gives us 5. Therefore, your answer is 6 to the 5th power. Let's look at example 2. X to the 4th power times x to the 5th power. Again, you have the same basis. So you're going to say your equal sign, and you have x, and you want to add your exponents, 4 plus 5. 4 plus 5 equals 9. Therefore, your answer is x to the 9th power. Let's look at example 3. It says x to the 4th power times y times x to the 2nd power times y to the 3rd power. So the first thing I suggest you do in problems like this, whenever you have a single y or a single variable, or even a single number, add the 1 next to it. And next you want to bring your like bases together. So we have your x's and your y's. So if we look here, we have x equals x to the 4th, because we have a 4 right here, and then x to the second. So you're going to add those. And then you want to multiply it by your y bases. So you do the same thing. You have y, and we have a 1 to the y, the first power, plus the third power for 3. Now your next step, add them up. So equals x, 4 plus 2 is 6, and then y, 1 plus 3 is 4. So your final answer is x to the 6th power times y to the 4th power. You want to get your bases together. And that is your answer. So get your bases together first, and then add your exponents. So what I'd like you to do is the U try section. Please complete A, B, C, D, and we'll discuss it in class. Now let's discuss the commutative property with exponents. So now let's discuss steps to using the commutative property when simplifying expressions with exponents. So let's our directions is to simplify the following expression. And our example here states 6x to the 5th power times 3x to the 4th power. How would you solve for this? We have 3 steps. Step 1 is you want to use the commutative property of multiplication. So we're going to use the commutative property of multiplication. And let's refresh what that means. We want to get our numbers together to multiply and our variables together to multiply. So you want to bring your numbers together, which are 6 and 3. So you write 6 times 3. And then you want to get your variables together, x to the 5th and x to the 4th. So you're going to times that by x to the 5th times x to the 4th. Now, step 2 states you want to multiply your constants, your numbers, and add the exponents. So step 2, we're going to multiply the constants, which are our numbers, and add the exponents. So we're going to multiply 6 times 3, which is 18, times you want to multiply your exponents. So we have the same base, which is x, and then you want to add your exponents, which is 5 plus 4. Then our last step, step 3, is to simplify. So our last step, step 3, is to simplify. So now we have 18x and 5 plus 4 is 9. And that is your answer. Let's do 2 more examples together. Example 2, negative 3x to the 2nd power times 5x to the 3rd power. Your first step is you want to use a commutative property of multiplication. So you're going to take out your numbers. You're going to say negative 3 times 5. And then you're going to pull out your variables. X to the 2nd times x to the 3rd. Next, you want to multiply your constants. 3 times 5 is negative 15. And then add our exponents. So we have x and then 2 plus 3. Therefore, our final answer is negative 15x and 2 plus 3 is 5. So negative 15x to the 5th power. Let's look at one more example. We have negative 4y to the 5th times negative 3y. Remember, when you have a single y, I would definitely put a 1 next to it. So we're going to put a 1. Okay, so now let's use the commutative property multiplication. We want to take our numbers, which is negative 4 times a negative 3, and put our numbers, our constants, together. And then you want to take your variables, which is y to the 5th times y to the 1st. Next step, multiply your numbers. Negative 4 times negative 3 is 12. And and then add your exponents. So you have y, because it's the same base, and then 5 plus 1. You can only add the exponents if they have the same base. Then our last step is to simplify. So we have 12y. 5 plus 1 is 6 to the 6th power. And that is your answer. So now let's look at another example discussing geometry application. And our directions here state find the area. And you're given our first shape is a rectangle. And we're given two sides, x squared and x to the 3rd power. Find the area. Let's recall, what is the area of a rectangle? How do we find it? Well, we find the area of a rectangle using our length times width. Or you can say also base times height. Doesn't matter, same formula. So now let's plug in what we know. What's our base? What's our height? What's our length? What's our width? Well, x to the 3rd power is our length, also our base. So just label that L. And then our width, or our height, is W. So now let's plug it in. Area equals x to the 3rd power, that's our length, times our width, which is x to the 2nd power. And these are the same bases. So now we can add our exponents. So equals x, and then 3 plus 2. And 3 plus 2 equals 5. Therefore, our area to that rectangle is x to the 5th power. And that is your answer. Let's look at the next one, number 2. And if you notice here, we have all dash marks. That means all sides are equal. Therefore, it is a square. Therefore, if one side is equal to x to the 5th power, the other side is also equal to x to the 5th power. So let's recall, how do you find the area of a square? Again, same formula. Area equals length times width. And we know the length here is x to the 5th, and the width is also x to the 5th. Just replace it. Our length is x to the 5th, and our width is x to the 5th. Our next step is you want to add your exponents. So it's the same base, so we have x, and we're going to add 5 plus 5. 5 plus 5 is 10. Therefore, the area is equal to x to the 10th power. And that is your answer. So now what I would like you to do is the you try section. Please complete problems 1, 2, 3, and 4, and we will discuss this in class. Thank you.